Hello and welcome to our channel again. So here I am Suraj again with a new video of mine where I will discuss about the Bohr's magneton. So this is basically I will make a short video explaining that what exactly the Bohr's magneton is and what does it represents. So as we all know that electron has a charge E. So electron has some type of charge and it moves around the nucleus according to the Bohr's model in a circular orbit. So if it's moving in a circular orbit, it means it creates some circular loop. It means imagine that this is a nucleus, and if electron is revolving around this nucleus having charge E in a time period, so it means there is also current. That's why current is known as the charge per unit time. Okay, so if there is an if it's moving a circular path or circular orbit, it has some of the current current loops, and it is also a very good concept that the moving charges created magnetic field. Moving charges created magnetic field, yeah, but we'll discuss about it. But first of all, we have to discuss that this is electron moving around the nucleus, having a charge E, and if it is charge E and it moves around the nucleus in a particular time period, it means it forms a current loop around this nucleus. Okay, so if it's currents the current loop around the nucleus, it also creates the magnetic field around its we say that around its positions, it creates the magnetic field. It means it also has the magnetic moment also. So the magnetic moment of an electron, magnetic moment, what's the magnetic moment? Yeah, we'll discuss about this in detail, maybe in the video where I will discuss the very deep concepts about the magnetic field, magnetic force, how that this behaves. So for now, the you can imagine that magnetic moment is denoted by this particular symbol, and the magnetic moment is nothing but it tells us that how a particular object behaves in when there is an external magnetic field. If suppose that there is an object has some magnetic moment, it means that it tells us that how this particular object behaves in the external field. And electron moving around the nucleus also creates magnetic field, and it also has the some of the magnetic moment. So if also has the magnetic moment, it means we can conclude that if has a magnetic moment, so we are going to calculate this particular magnetic moment, and the magnetic moment is what known as Bohr's magneton. The magnetic moment of an electron moving around the nucleus, if there is an from the r distance. And why it has? Because it's moving around because of its orbital angular momentum known as L. So L is orbital angular momentum, formula is mv into r. Okay, so this due to this orbital angular momentum, there is a electron moves around the orbit and created the magnetic field. Okay, but there is also the spin momentum. Spin is the momentum of the electron moving around its own axis. Okay, but spin is very different, as you can imagine, and spins require a very detailed analysis of these topics. That way we'll discuss spin in the maybe in very when we do the advanced quantum mechanics, then we can describe it what exactly the spin is. Electrons are not the charge which is rotating around its axis. It is not like this. Okay, but we are not going very detailed in this topic. Now we are going to only define the magnetic moment created by the electron due to the angular momentums, is orbital angular momentum, which is mv into the r. So now we are going to derive that particular expression. Okay, so what is the time period of an electron moving around the nucleus having the speed v? So the time period is equals to the 2 pi r upon v. So this is will be the time period. So this is the time period. Now we're going to calculate the magnetic moment of that particular electrons. Okay, so we are going to calculate the magnetic moment. So current is equals to the charge upon time, and if I substitute the value of time as 2 pi r upon v, what we will get is the EV upon 2 pi r. Okay, by substituting a t from this particular equation. So this is a very important equation. Putting those equation in this equation, we get this particular value. Okay, but we have to define the magnetic moment. So what's the formula of the magnetic moment? So remember, magnetic moment is equals to the current into the area. So the area of this circle can be determined by the formula pi r square. It means time period is given and area is also given, which is equals to the pi r square of a circle. And after doing this, we can substitute or we can find out the u as following. So what we can do is that we can discuss u is equals to the I into the A. And now after this, what we can conclude is that this magnetic moment is equals to the putting the value of E as EV upon 2 pi r into pi r square. So what we can conclude is that pi and pi will cut out, this particular r and r will cut out, and what will left is with that ev upon 2 into the r. So this is the expression of the magnetic moment of an electron moving around the nucleus and having the charge E. There is also another expression for this particular. Okay, so how we can define the magnetic moment in terms of it angular moment, orbital angular momentum. So how I can define this? So we know that the orbital angular momentum as written here is equals to the L is equals to mv into r. So in this expression, if I multiplied here, if I multiplied it by m and divided by 2m, we can get that this particular expression become u is equals to the mrv is equals to the orbital angular momentum E upon 2ml. So this is the expression for the magnetic moment of an electron moving around nucleus. So this is a short video where I'll explain about the Bohr's magneton, but don't worry, because I will make a very long video on explaining this particular topics when we study the deep electric chapter, deep quantum mechanics. So thank you for watching my video.